Good afternoon, linear algebra students, or whenever you're watching this, so it could be in the morning, in this case, good morning. All right, so the point of this video is to solve the end of section exercise of the section 1.5, solution sets. Okay, I forgot the S. And this is the exercise. Write the solution set of both this system, which is a non-homogeneous system, and its associated homogeneous system. Okay? So we need to make a very clear distinction. So I will solve the non-homogeneous system in blue. Okay? And when I'm talking about AX equals B, I'm talking about that. Okay? So this system. And the associated homogeneous system is going to be AX equal 0. Okay, so we want to write the solution set of both systems and verify that the general solution is a particular solution P to the non-homogeneous system, that's actually very important, plus the general solution of the homogeneous system. Okay, so I have pretty much half the board to solve the problem, which is kind of funny. Okay, so obviously, let's start with this system. Let's start by writing the matrix of it. 1, 1, 1, and then 3. Then 2, 3, 3, then 6. And it's very easy to solve. So I'm actually going to do the row reduction because I have the time. You can skip the row reduction if you're doing it well. So first we're doing row 2 becomes row 2 minus 2 row 1. And the matrix will become 1, 1, 1, 3. And then 0, 1, 1, and 0. Okay, so that's what we get here. And then don't forget, so in this case, it's in row echelon form, and our pivots are here, which means we have to eliminate this one. So we're doing row 1 becomes row 1 minus row 2. And what we achieve here is 1, 0, and 0 with 3. And then we have 0, 1, 1, 0. All right. Now, first of all, remember that you have two basic variables, so x1 and x2. So here we go. Like this will be x1, this will be x2. And the free variable is x3. So we're going to say here x3 is equal to t. So let's write directly the vector x. Okay. And here we can go rather fast. Okay. I'm going to give you a tip. So, well, actually, okay, we will go like fast enough. Let's put it this way. But eventually you can even skip the step that I'm going to do. So x1, that's just equal 3, you see? So there is no x3 in there. There is no t that we bring on the other side. So actually, let's write t plus 0t, like this. Now, x2 is going to be, there will be like 0, let's say, plus minus 1t actually. So minus t, or let's write the minus 1t. It's actually nicer. And finally, x3 is equal to t. So we can write 0 plus 1t. Then, as we split these vectors and factor out t, we get the vector 3, 0, 0 plus t times the vector 0, negative 1, 1. Okay, so we have here 3, 0. Then we have the vector 0, negative 1. And then we have the vector 0, 1. with a little bit of practice, you can actually jump straight from here to here. It does take practice though. Okay? So what this means is that the solution set will be, so this vector, so 3, 0, 0, plus the span of this vector. So then we can just rewrite, so 3, 0, 0, -1, and finally 0, 1. Okay, so this is part of our answer. This is the solution set of AX equals B, right? So actually, let's write it down. So of AX equals B. Now at the bottom, let's do the same for AX equal 0. So now we're going to do the associated homogeneous system. And its matrix, so in other words, instead of these constants, you will have zeros. So its matrix will be exactly this one, 1, 1, 1. But instead of 3, you have 0. Okay? So you have like 2, 3, 3, 0. Now, what I said in class, but you can actually do it if you don't believe me, you can like row reduce in the same way, is that as you go to the reduced row echelon form, you get the exact same coefficient matrix as this, but instead of the 3, 0, you just get 0, 0. Okay, so you get like 1, 0, 0, 0, and then 0, 1, 1, 0. All right, so at this point, I have everything I need. I think I can erase the question. I will actually erase everything but the last sentence because it's going to be important. And I'm going to finish the question on the top here. So what does it mean? Well, we can do the same thing as what we have done over here. And since I'm doing it for the second time, I will show you the trick that will allow you to go faster. Okay, x3 is equal to t. Now we have here x1 and x2. So here directly, we will write that x, so x homogeneous if you want, just to distinguish it. Okay, so here you have the zeros. So just for the fun of it, I will write the zero vector. So we have like the constants over here. So the first equation will read as 0 plus 0t. Okay, so like this. So actually, look at this. You can fill this canvas and then you just read, right? So 0 plus 0t. Okay, so that's the first one. The second one is going to be 0 minus 1t. And the third solution, the third component, which is just t, will be also 0 plus 1t. So in other words, obviously, you don't have to write this vector because it's the zero vector. You're getting t multiplied by the vector here, like 0, 0, negative 1, 1. So from there, as you can see, the solution set of AX equal 0. So that is going to be just the span of the vector that we have over here. So 0, -1, and 1. Now, have a look at the general solution. Now, this is important, okay? So general solution of AX equals B. So it is the one that we have over here. So in other words, now I will change my color code. So it's this vector right here that I will write like, and let's actually write X equals. So X equals. So we have this vector right here, 3, 0, 0, plus T times, and this vector, right, actually I'll write this in green, plus T times the vector that we have here. And then I need to erase that sentence, which I think will be enough. And then what I want you to notice is that the general solution of AX equals 0 is just this. So it is XH that is equal to T times the vector 0, -1, 1. So this verifies the theorem that we have seen in class, that the general solution of AX equals B. So in other words, let's actually not write this. Let's write that X is equal to this, which is the particular solution, plus XH. Okay, but when I write this, I'm writing here the general solution of AX equals B is equal to particular solution of AX equals B plus, and this is the general solution of AX equals 0. All right, I hope this video helped. So this is the exercise of the end of the section. Remember, you have to give it in with your lecture notes of this week. And next class, we're starting section 1.7. Here we go.